All right, so welcome back. Week 9. Now we are halfway through the semester. Only halfway. All right, so we began last week our module on um, HTTP and secure web services. So we've moved past the module on cryptography alone, right? And so last week we started making our own APIs, and I'm going to take a look at those maybe after class today. If we have, maybe during class, we'll see. Um, and any any troubles or questions that you had in making the APIs for today? No? Yes? Question. Oh, okay. You're not sure if you're using post correctly. Is that right? Okay, okay. I'm sorry. Are you asking about submitting forms, or what are you asking about? Okay, about the model. Oh, okay, 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 okay. Let's talk about that. So you want users to be able to upload PDFs, is that right? No. Okay. They need to write a post online, like some text, and then they need to submit it. Okay. So, oh, okay, okay, okay. I see, I see. So right now we're not dealing with a user interface. So assume you have another application that's getting this user input, and that other application is just posting it to your API. So don't worry about user interface. Just assume some other agent is sending you this text that the user has written. Okay? Does that answer your question? No? Ask me after class, maybe. All right? Or write it up, and I can understand it better. Anybody else have any doubts or questions? Should we turn on an AC in here or open a window? Anything? Doesn't help? Turn on AC? Yes, you're paying for it. Might as well. Huh? Is this working? I have no idea. I feel it. I feel it though. I can feel it. Okay. All right. So I can feel there's air moving in the room a little bit. I can feel it in the edge at least. Maybe this one, maybe it's working. If that paper doesn't. Oh. Okay, 1 second. How's that? No? Or maybe just turn it off and turn it on again. All right. Or would you like me to turn the fans on? See, I can hear it. Oh. It's from the same power source or what? Okay. Let's see if this works, okay? There's cool air moving now in the room somewhere. Okay, so any other questions about let's take a look at so I may have forgotten to mention, but I hope I let's take a look at actually I forgot to post it on my own one. Oh, API available here. Team A. Where's Team A? Hello, Team A. Yeah, please do. You can do it right now if you wish. I haven't looked yet, so okay. Uh, you didn't change the README? No problem. Okay. So this is the general idea. You've got your app. So I didn't really go into it in a lot of detail, but you've actually made a kind of MVC application, a model view controller architecture, okay? Because you've got controllers, which is the code that is essentially taking routing the request to the correct place. So this is the code that's handling requests and sending back responses. Okay. We've got models. So this case models, we're going to use a, I'm not happy with the sense of the word, but it's basically representing our data and our logic. All right. So we've got models, and there's no particular logic here, except it's just storing, reading, and writing from a file system right now. Okay. All right. Cool. But it does represent like some of the major resources. All right. Hey, is this still called? Is yours also called document? Okay. Is it different from my document in some way? Okay. A lot? What's different? Okay. Okay. Wow. Okay. Got it. Got it. So actually, the controller is going to then have to tease apart the request object quite carefully. So if I can take a look at your controller, um, doesn't look so bad. What's the complicated part? In the post? In the post? Oh, I see. Okay, okay. So document you you pass in the whole request params to the document. All right. Okay. Maybe later we will have an intermediary class to kind of separate those things out because your model shouldn't really be like knowledgeable about request parameters from HTTP, right? But that's okay. And so then in your model, you're essentially taking in. So this new document is actually params. It is the params. It is the params. Okay, okay, fine, fine, fine. That works fine. You don't have to parse it specially in here. Okay, all right, cool. I notice you have an author ID in here, but you don't have an author model yet, right? One request I ask is that you don't create user accounts yet. So just pretend this exists somewhere else. Pretend the author will come eventually, okay? But don't model the author quite yet. Okay, cool. All right. Any other team would like to show me what they have? All right, Team B. All right. Um, your models are, you have contacts. Is that right? It's kind of like a phone book right now. Okay. At this stage, so you just have a name and a number, right? Okay, cool. And you are also generating a new ID the way I suggested. All right, cool. Um, and were you able to get some tests working? That's another story. Okay. um, looks like you made an attempt. But by the way, please run Robocop on your code because its formatting is really weird. All right. So run Robocop on your code. It'll. Okay. Which formatter are you using? Huh? Prettier. Hmm. Probably not. Please run it through Robocop and fix it accordingly. Okay. For example, tabs should be just two spaces, not what on earth is this? Six generous spaces. Okay. All right. Cool. Um, I'll look through some more soon. All right. Teams Gamma, where are you? Hi. Okay. And what's your model that you were working on? Posts, blog posts, blog posts. Okay, all right. Is it a blog post or some other kind of post? Blog post? Maybe call it blog post because post can be anything, right? So just make it a blog post. All right. I think. Well, let's see. We'll as we go through the weeks, we'll see. All right. Cool. All right. And sounds good. Did you get your tests working? Yes. Huh? Okay. You seem very confident. Okay. All right. Great. So I won't look at all of them right now. Maybe we'll look at some more later on. So you've got this idea of creating a very simple web API, and it can take in GET requests and POST requests, and I'll maybe talk about those some other time, the distinctions, and um, and also creating these basic models. All right. However, for now, the data that's coming in, we're just storing it on the local file system, right? And I want you to kind of get a sense of like what that feels like and what that is like, because then we can talk about what are the problems with just using a file system or any kind of arbitrary data storage. All right. Um, so, any thoughts on what are some of the in my projects, so this is like I was mentioning this last time. So my project idea is to have a team of developers be able to share credentials or tokens and things that their application needs securely in one place. It's an issue that at least students working with me we also deal with when we're taking a project over from another team, how to share those credentials securely. Okay. Um, okay. And what else? So this is kind of sort of like the API we're going towards. However, for now, we've stored things in a local database. Any comments or questions or thoughts about what's not safe about what we're doing right now? Anything? Anything insecure or an issue, security issues about what we've created so far? What's that? The way that you receive your data, what's wrong with it? Okay, it's not on an encrypted channel. It's just kind of like sent over the internet. Anyone intercepting your traffic will be able to read it quite clearly. All right. Yenu, my content is not encrypted. Is that the same thing what he just said? Like it's sent to the server unencrypted? Is that the issue? Okay. All right. So we have some issues, people who feel like we should be sending it more securely to the server. Did you have another comment? Oh, okay, yeah, we're not checking anything. Actually, people could send whatever the hell they want, and we will just save it anyway. We're not really checking the validity of what we're being sent. All right, cool. Anything else? Anything else? No? APIs are not annoying. I can't say I've solved that problem. Let's take a look at some other possible things. How are we storing this information right now? We're not even storing it in an encrypted format. So whatever people are sending it to us, we're just storing it on disk, and we're hoping that nobody except us can get access to the server, right? That is not a good strategy because getting access to a server, it's not easy, but it's doable, right? It just takes figuring out some credentials and people can kind of like walk into our server. So the way we're storing it is also in a vulnerable situation. Or, for example, maybe somebody breaks into our building and just steals the server, right? Maybe they don't have to even come in over the internet. Just saving potentially confidential things in this kind of way is insecure because it's anyone who with access to our database, to our file system, can read it. Okay. Um, is it possible that somebody can read our stuff without breaking in to our server somehow? Yes, how? If you were tasked, not you were tasked, but like, is there any other possible source of threat? Somebody can read our data even without even hacking into our server per se. Oh, fantastic. Yeah. They can just use the API, right? I mean, we made an API, it gets resources. We're not checking who's asking. If they know what our API looks like, they'll come and they'll just grab whatever they want. Definitely. We have no authorization built in, all right? And no authentication built in. So right now we don't care who it is or what they want. We just give it to whoever asks. Okay. So that's definitely an issue that we'll be fixing in the coming weeks and months. All right. Um, any other way? Imagine I did have authorization and authentication on this API we made today. Imagine we did have it. Any other way people could try to gain access to this data? Yeah? Pushes what? Oh, you mean the data files themselves. Okay, if you make a mistake as a developer and you add the data store to GitHub, you're done, right? That'll be terrible. Yes, that's true. Any other way? There is one other form of attack that's increasingly becoming, I won't say prevalent, but we are increasingly aware of this type of attack, which is your code is not the only code running on your server, right? There's other applications running on the server. If it's at all possible for an attacker to make you download another version of those other applications and services running on your server, they might be able to access your server. Um, a very maybe a more complicated example might be there might be maybe when you're downloading maybe when you're installing Linux on your machine, maybe if somebody can get you to download an infected version of Linux, then you've got an infected machine and they've got a backdoor into seeing everything you're doing. But that's a little bit difficult, not impossible, but a little bit difficult. um, there's a news story that broke yesterday. I don't know if anybody saw this. Not with PHP, around Linux. Some researchers at the University of Minnesota intentionally submitted security vulnerabilities into the Linux kernel as an experiment to see if they would get added to Linux. And and then they published a paper saying, "Hey, we were able to get security flaws pushed into Linux by submitting patches with really complicated-looking code that nobody could understand." And this caused a huge scandal, and the University of Minnesota has been banned from working on Linux entirely. And the university is having to do a big investigation to see how they allowed such a thing to happen, because apparently it went through an internal review board and everything. So anyway, but it is possible that some open source that you're running on your server is reading whatever's happening on your server, because you just install these packages on Linux. You don't really know who made it, it seems like something you needed, so you install a whole bunch of packages. It's possible one of those packages is either reading your drive, in which case they can see all the data you're storing. It's possible if you run one of those processes from within your process, they will have access to your environment variables, and they will know all your credentials and everything, and they'll know how to read your database and everything. All right. And in particular, one particular source of worry is the gems that you're downloading. A lot of us as developers, sometimes we need a package, like your team needed. What package? No, you're not using a package in the code itself. But if you need a package to, like, let's say, parse a PDF or an image or something, you might just kind of like include a package into a gem into your application. But how do you know that gem is actually safe? What if maybe it just wasn't written very well and it has some security vulnerabilities? That's one possibility. All right. The gems you're using might have bugs in them that people are exploiting to break into your application. All right. But secondly, it's also possible that the gems you're installing are malicious. They're actually written by somebody to fool you and it maybe has some functionality, but it's actually also giving them a backdoor in. All right. So so another source of vulnerability is simply that anyone can find ways to get into your server through other software packages that you're installing and using. And it is an increasingly common way of doing things, right? All right, let's move on. What else? So I already mentioned that the things stored on your server are not stored secure, which is becoming easier by the day. They can read everything, all right? That random number generator, remember that, you know how we created new IDs? We just took the current time and we hashed it. um, is it possible to have a collision there? Collision meaning two documents or resources have the same exact ID? It might be possible, maybe, if two requests come in at exactly the same time. And you know your server might process them a little bit later, but the timestamp, if it's somehow exactly the same, you're going to generate the same ID twice. Okay, so that may or may not be the best way to generate IDs. All right, so we're using a random number generator, but that may or may not be the best way because we're essentially, I think, just hashing some time information. All right, what else? Bu- 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 bum. Okay. We're and I think Brandon mentioned this, that yeah, we're not doing any checks, so it's also possible that even though we are generating the ID ourselves, somebody could just send in an ID as well. Like somebody could post a resource with an ID already in it, and if you have a resource with that ID, it might get wiped out. All right. Yeah, that's a yeah, definitely that's a bug, right? Um, what else? And okay, and I mentioned this one. Dependencies gems could have vulnerabilities. All right. Um, there's one more thing, which is we may not think of it as a security threat, but remember, if we think of security in the broad sense of the term that we discussed in the first day of class, which is anything that adds like fear or uncertainty or doubt to the service. One is, since we're using a local file system, this project is not really scalable. Why? Because let's say your service is suddenly a big hit, thousands of people come in, tens of hundreds of thousands, maybe millions of people come in, and your one little server is under a lot of strain. Could you scale this server up? Could you make two servers? Probably not the way we're doing it right now, because the data is just stored in the local file system of a single server. If you want to scale up, you really can't do that because if you had another server, well, then your data is in two different machines, right? So you can't really access data across both machines. So a file system is not the way to produce a local file system is not the way to produce a scalable data solution. All right. So there's these and other threats that are kind of facing our system. So we'll start slowly, week by week, trying to address some of these. All right. Okay. All right. So I'm going to get into a whole bunch of stuff today about different tools and techniques. And one of the big things will be how to have a actual database instead of this kind of hokey file system thing. Okay. At least we'll make a move in that direction today. We will not finish that direction today. All right. Question. Okay. Good. Yeah. Like phishing attacks, you mean? Something like that? Yeah. Okay. So we will try to talk about that. So a ransom attack is basically where somebody has hijacked your data and is telling you they've got into your server, they've taken your data, and they tell you we've just wiped your database out, but we kept a copy. If you want your data back, pay us in bitcoins, something like this. Um, One obvious thing that you want, there's a couple of obvious things. One is you need to have backups of your data, like offsite. Okay, and I won't talk about that maybe today, but maybe at some point in time, I might show you how you can do that with the resources we're using this semester. Okay. But the other thing to consider is if somebody steals your data, Can they read the data? Because if they can read the data, it doesn't matter. It matters less that you don't have the data. What matters more is somebody else has your data. So confidentiality, Edgar, is one of the things that we will talk about. All right. Okay. Cool. All right. So let's start discussing some of these vulnerabilities. Before we do that, there's going to be a lot of tools we'll be using in this class. Some of it command line, and already you're doing a few things on the command line, right? Like you have to do rack up to get your API up and running. You have to you're saying you're using Robocop on the command line to kind of do style checks on your code. You're running your tests using API, running the spec API specs RB. So, and there's going to be more and more things we have to do on the command line. And after a while, it gets really, really annoying to have so many different things that you have to remember how to type. So I would like to kind of introduce you to a very simple tool that kind of tries to automate some of the command line tasks that we want to do. All right. And the tool that I want to introduce you to, and those of you who have taken my SOA class will be familiar with it, is called Rake. Anybody used Rake before? Okay, to take my class. Okay, you've used Rake. Some people know how to use Rake. Okay, so let me just show you what it does essentially. All right. So Rake allows you to create a file, which we call a Rake file, where you can specify command line tasks that are commonly run by your application, and you can specify how to run those with some small commands. Okay, so let's try to look at some examples. So in my Rake file, for example, I have a task here. So remember, like to run my tests, I have to say Ruby spec API spec RB blah blah blah, right? I have to write. You typically type something like this. It's easy to make some typos as you're trying to do this kind of thing. All right. So one thing I want to be able to do is not have to type this long thing out every single time and remember where my test file is or what my test file is. Instead, I'd like to be able to run my tests very simply, and I can do that by just saying rake spec, or is it API spec in this case? API spec, excuse me. Okay. And when I do that, it actually runs this Ruby spec API spec.rb for me. All right. So I've saved myself a little bit of having to remember what is the file name of this thing again. All right. So it just lets me automate some of my tests. There's something wrong with my tests. Let's see what's going on. It's not exactly running all my tests here. Okay. No, I've got another one here. Sorry. Rake spec. This runs all my tests. All right. So then you'll see it's going to run. I got like 5 or 6 or 7 different tests that are running. All right. Okay. What else? I have to run Robocop once in a while. And maybe when you run Robocop, it's possible that you have to specify some things about what to run and what not to run. I just made a very simple script called Rake Style. And this essentially just calls Robocop for me and inspects all my code and makes sure that there's no problems. All right. What else do I have? Well, I'm going to have a whole bunch of others that I'll introduce as the class goes on. All right. So essentially, Rake File is a place where you can create tasks that you have to run on the command line and give them like just helpful little names. So you can just call those by name very quickly. You can say Rake and a certain task, and then it'll run the code that is necessary to run that task. All right. Essentially, it's automating all the stuff that you have to do on the command line. All right. So the examples I kind of gave you was Rake spec and Rake style. So it just kind of runs whatever needs to be done. Also, the nice thing is if somebody new joins my project and they have to run my tests, they don't have to go figure out, oh, where are the test files? What are they called? How do I run them? They just say Rake spec. All right. And actually, in most Ruby applications, like if you find on GitHub, if you install them and run bundle install, you can run their test by just running Rake spec or just Rake. All right. And that way, programmers have a convention that Rake spec is simply the task to call to run all the tests. All right. And a new developer doesn't have to know what are all the different test files, where are they, and so on and so forth. Okay. Any questions about this? Why we need this, or what this is for? No? You're too trusting. Is there anything that you're running right now on the command line every time when you're working that could be automated maybe? Yes? No? I'll show you some more examples of things that we'll have to run from the command line and how we can automate it using Rake. All right. Rake is obviously it's a Ruby gem, and curiously, I've found a lot of developers who use Rake, and they're not actually Ruby programmers at all. It's a very popular tool for just automating command line code. You need to know a little bit of Ruby because the Rake file is actually written in Ruby. But I know a lot of projects, including like data analytics projects and others, where people use Rake as their command line automation tool. So it's not just used by Ruby programmers; it's actually used quite a bit in all types of other projects. Okay, there are similar tools for other languages. So if you're coming from C, C++, you've obviously heard of Make, right? Java has things like Maven and Gradle. JavaScript has Grunt, Gulp, tools like this. Python has something called Fabric and others. Has anybody used a tool like this? Any of these tools? Which ones? Joe? Gradle for Java. Okay, cool. Anybody else? Any JavaScript programmers in here? No? Yeah, you okay? Hello. Good morning. Uh, have you used any of these tools? You've used these? Okay, cool. All right. Anybody else in any other language? Meson? Meson, Meson? For which language? Also C++, Meson? I've never heard of that before. That's very interesting. Mesons for C++? Meson build system. Huh, cool. I didn't know this. I thought C++ programmers were still using Make. All right, cool. Oh, I see. So it's kind of like an all-in-one thing. Okay, cool, cool. All right. Anybody else? Any Swift programmers in here? Anybody write in Swift? No. Okay. Just wondering what language they're using, what tools they're using. All right. So Rake is a tool that just allows you to basically say, I have a task. You give it the name of the task, and then what you want to run. So let's take a look at one of them. So here's a simple one. No, that's not simple. This is a simple one. All right. So I have a task. I call it API spec. And if I run this task, it essentially, this is all Ruby code. It calls the shell command ruby spec / API spec.rb. All right. So it just runs that command for me essentially. So this is a simple example of a task. All right. And you'll notice above each task, there's a line that describes the task as well. All right. All right. Here's another example of a task. And this kind of begins to show you a little bit of the power of this kind of tool. So I have a task called style. All right. And style should, actually, I think I haven't quite done this yet. My code is a little bit different. So style. And what I had before was simply that if I run rake style, it'll just call Robocop on the current folder. All right. But here's something else I can do. I can tell Rake that anytime somebody wants to run this task called style, first make them first run the task called spec. So this way, for example, I can say that anybody who wants to like do a style check on the code, it'll first run all the tests on it to begin with. Okay. Why? Because it's generally a bad practice to fix your style before all the tests are working. Like first get your tests working and then fix your style. And this will enforce it for my team. So now if somebody says, if somebody says rake style, this will first run all the tests and then it'll run Robocop, right? So you can kind of create dependencies, and not just one. You can have multiple dependencies. I could give it an array of tasks that it has to run. So, so essentially, you can create dependencies between tasks. You can also create dependencies between tasks and files. You can say that run this task, but only if this file has been changed. Some things like that. Okay. So there's a lot of interesting things you can do. One more example is this. Some gems, like Rake, the gem Rake, comes with its own built-in tasks that you can call. So, for example, the Rake gem comes with a task called test task. This essentially says I want to run tests, and it's basically a task that will run all your tests for you. You just have to specify a few things. For example, what is going to be the name of this task? So I'll say the name of the task is going to be spec. Where are all your tests? So you tell it the pattern of my tests is that they're all in the specs folder and called star underscore spec. All right. And this is saying if there are any warnings while the tests are running, then don't show them. So something like this. And this will just take care of running all the tests for me. So I don't have to now go and like find all my tests and run them one by one. It'll simply run all my tests in the spec folder. Okay. So there's some gems come with built-in tasks, just so you know. All right. Okay. So I'll show you some more examples of helpful tasks. We'll see a bunch of them today itself. All right. So let's move on. So one of the vulnerabilities I mentioned about our project is that we're increasingly calling other packages and gems, and we don't really know if those packages or gems have bugs or problems with them. All right. And I think I talked about this earlier in the semester. There are tools out there that can look through all your gems and tell you if any of those gems have known bugs or problems. Um, and this is generally called auditing your packages, right? And in fact, GitHub does that for you for free. If you have a Ruby project on GitHub, it will occasionally email you and say, hey, one of your packages is using a gem, and that gem has a known vulnerability or bug in it. Please update that gem. All right, so that's kind of cool. GitHub will do that for you for free. All right. However, you may not want to wait until you have uploaded your code to GitHub to find out that there's vulnerabilities with your gems. Earlier in the semester, and I think we may have forgotten this, we saw a gem called Bundler Audit. Does anybody remember this? We saw this way early in the semester, all right? And this is a gem that will simply look through your gem file and your gemfile.lock, look at all the versions of the gems you're using and tell you if you're using some versions of gems that have known security issues, bugs, etc. Okay? And so this gem is called Bundler Audit. So I highly recommend that in your project's gem file, I don't highly recommend it, I require it. Please put Bundler Audit as one of the gems that you will use in this project, okay? To run this gem from the command line, to run this gem, you would have to write, the best way to run this gem is from the command line to run bundle audit check dash dash update. This runs the audit on all your gems. It calls bundler audit, it runs the audit, it checks all your gems, but before it does it, it actually updates its own internal database of known vulnerabilities. So it goes over the internet and downloads a list of known vulnerabilities. It updates that list, kind of like an antivirus software, and then it checks all your gems for you, okay? And I suggest you run this regularly before you upload any code to GitHub, all right? Once again, it's a pain in the ass to type bundler audit check dash dash update. You just will stop doing it after a while. So why don't we make life easy for ourselves? We can just make a task that does this for us called audit, all right? And now, if you say rake audit, it'll check everything and tell me, okay, all your gems look okay from what we know. There are no reported vulnerabilities that we know of, okay? So one of the things I'd like you to do this week is please add bundler audit to your workflow. What you can even do is, if you wish, you could make this task a dependency for some other task. Like, for example, let me go here and where was it? For style. So whenever people are checking running Robocop, I'm running the test first, but I could also just run the audit at the same time. All right. That way, I'm not tempted to like clean up my style of my code until all the tests pass and known vulnerabilities are eliminated. Okay. So now if I run rake style, this will quickly run all my tests, do the auditing, and then check my style for me. All right. Again, a really nice use of rake to just accomplish multiple tasks at the same time. Cool. Um, By the way, what do you do if you do find a vulnerability, like this example? So if you run Rake Audit and it tells you, warning, warning, there's a possibility of attacks that are possible through these gems. For example, this was a few years ago, and this tells you that this version of Rack that you're using, it's vulnerable to DOS attacks. Anybody know what a DOS attack is? What's that? DDoS? What is DDoS? Okay, but what does it stand for? Yeah, denial of service. Essentially means that there's a way to to send a message to your server that triggers a huge response from your server. Such a huge response that it just floods the capabilities of your server. Like you basically go down because you're trying to handle this request. Okay. For example, it could be a simple thing like it sends you let's say an image whereas you were expecting a little bit of text, and maybe you're doing some parsing through some text, but by sending you an image file, it's like takes up 1,000 times as much time as a text file would have, something like that. Okay. Or maybe it sends you a signal that sends your code into like a loop or something like this, but it essentially occupies all this processing power of your computer. Yeah. So the basic type of attack is called a denial of service. What a DDoS is, a distributed denial of service. So that's where you to get a that you use a DDoS when you cannot find an easy way to conduct a DOS attack. So let's say you're trying to attack a server, and if there's a bug in the software, then it's really nice. You can go send a very small message, and that small message causes a massive response in the server, and the server just hangs trying to deal with that request for some reason. Okay, so they found a problem like that in Rack, in the Rack gem that we're using. A distributed denial of service is when you can't find a small thing that triggers this kind of a response. So instead, what you do is you marshal, let's say, 1,000 or 100,000 computers to simultaneously send small requests to the victim. All right. So you send too many requests for them to handle. That's a distributed denial of service. However, very few people are able to conduct a distributed denial of service because you have to have something like a botnet. You have to have some kind of network of computers that you can command to send this kind of an attack. A simple denial of service is much more lethal because literally anybody on the internet could send you a message that brings your server down. All right. So this is an example. There was also a vulnerability for a cross-site scripting attack, which we'll talk about later this semester. All right. So running the bundler audit told me, bam, 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 this version of this gem that you're using has problems. Please update it. All right. And if you do have to do that, then all you got to do is go to your gem file. And for example, in my case, I don't, Rack is not in my gem file because it's part of, what is it part of? Rhoda. It's a dependency of Rhoda. So I never specified Rack myself. Rhoda has it already included. But if I'm told that there's a vulnerability, and usually it will also tell you the solution is upgrade to a specific version of this gem. Okay, and in that case, you need to explicitly say, I want this gem at this version or above. All right. Okay, cool. Um, so, and then bundle again and get that correct version put in. All right. Okay, cool. Any questions about bundle or audit? You're okay? So this is So as I mentioned in the beginning of the class, one of the biggest vulnerabilities of your software is all those third-party packages and gems that you're installing. So use bundler audit to make sure you're getting legitimate versions without bugs in them. All right. It's also possible that the code you are writing, so forget the gems, maybe your own code is written in a way that it is vulnerable to something like a denial of service attack. Maybe there's a way that somebody can send you something, and the way your code is written will take excessively long time to process it for some reason. Okay, so it's also a good idea to ensure that the code you're writing, superficially at least, doesn't have any kind of loops or structures in it that could cause a major problem or slow down your service. Okay, it's very easy in Ruby to write very unperformant code because you take an array, you do a map on it, then you do a reduce, then you do a select on it, then you do a each on it, and then you're writing loop after loop after loop. All right, so it's very easy to write unperformant code in Ruby. So there's a gem out there called Robocop Performance, which actually analyzes your code to tell you if there's any structures of code that look obviously, what's the word, inefficient. That looks inefficient, obviously, even with a static analysis. Okay. Um, so I won't go through it, but it's got a whole bunch of little rules built into it. And you can go take a look at some of them in your own time. Maybe I'll go take a look at one of them to see like what this is all about. All right. Oops, does not exist. Robocop Performance. I gotta update this link. Performance. Ed, please remind me to update this link. Click. GitHub, where are you? Okay. And hopefully somewhere here, it's, let's go to the official docs. And let's look at the cops. So these are all the rules that it'll check for. I don't even know what most of these rules are. Let's see. Let's look at one of them that looks interesting. Chain array allocation. What does this mean? So you have an array and you call compact flatten map on it. I have no idea why that's bad. It says, oh, because each of these will generate, so when you call compact on the array, it will generate a new array. When you call flatten on that array, it'll generate a new array. When you call map on that, it'll generate a new array. So your memory is getting quickly used up by these little chaining all these iterations along. So instead, it suggests to you, if you want better performance, use these dangerous functions, these bang functions. This exclamation mark is called a bang. Use these bang functions, which basically mutates the original array rather than allocating another array. Okay. It's debatable whether this is good Ruby style or not, but it'll definitely be more performance. All right. So this, yeah, question. Yeah, that's right. Robocop will say, "What are you doing?" No problem. Just take this and make it a new function. Make it a new method called array compact flatten map underscore underscore underscore. All right, and it'll be a high performance version of array.compact map. All right, yeah, but no, this is a really good comment because I did have this comment from a previous semester's class where somebody told me there was a performance issue, and when they fixed the performance issue, then Robocop said, this style sucks, So, but at least then your team can make a debate, can say, do we want the more performant version or the more readable version? All right. So, but if you just do this, you don't even know that maybe you've done something dangerous. Okay. Not dangerous, performant, slow performance. So again, imagine that this array wasn't 3 characters. Imagine it was like 20 megabytes. And then this first command now generates another 20 megabytes. This generates another 20. This generates another 20. So you can quickly inflate and occupy memory. All right. So, all right. So anyway, to use this gem, please put it in your gem file. I have a performance section in my gem file where I put this gem, Robocop Performance. And then to get it working in your robocop.yaml file, your .robocop.yaml file, the first thing I have is I say require Robocop Performance. And this incorporates all the rules of that gem as well. Okay, cool. Any questions on this Robocop Performance? I don't think so. You mean if you just want to run the performance ones? I don't know. Good question. I really don't know. I'm sure maybe Robocop itself has some flag that you can set to say just run the performance gems. And if you can find that flag, then you can make a rake task that will do that. But I don't know. Please find out. That's a good question. The danger of asking questions. I'm like, you find out. All right, cool. All right, okay, so we're going to start talking about how to build a database today. But before we do that, just again, today's class is going to be a refresher for students who took my previous SOA class. But just to make sure we're all on the same playing field, before we go about creating a real database today, I want to remind you a little bit about a good coding practice. All right, which is, generally speaking, when we are running our code should be aware of whether it is running in development mode, which means it's running on your laptop, the developer's laptop, and everything is safe. Or if it's being tested right now, okay? Or if it's in what we call staging or production. Production is when it's like on the final server live and everyone and your customers are actually using it, okay? It's often useful for your application to know what environment it's in. Is it just running on your developer laptop, or is it running on production and users are really using it? Why? Because depending on which environment it's running in, it might do slightly different things. All right. Today's example we'll see is the database we're using will depend on which environment you're running on. If you're running on production, we're going to have a heavyweight, serious database like Postgres or Oracle or something. All right, hopefully not Oracle, but maybe Postgres, MySQL, SQL Server, something else. Okay. However, I don't want to run Postgres or SQL Server on my little laptop. Okay, it's going to kill my resources. So I'm going to run a very lightweight database on my laptop. So when I run my API, it needs to know, am I in production mode or am I in development mode? Okay. Also, and this is very critical, if you are in test mode, you want to have a completely different database. Because in test mode, I'll be like adding records, deleting records, wiping out the database, doing all kinds of funny things to the database. You do not want to do that in production by accident. So you want to make sure, for example, when your tests run, that they are running in a test environment with the correct database, the test database, not the production database, okay? So your code needs to be aware what's environment it's currently running in so that it uses the correct resources, all right? Also, and I'll show you later, there are some gems that I am using only in development mode because they help me with debugging. I don't want those gems to be running in production mode because they may introduce more vulnerabilities into my software. All right. So it's kind of important. Any questions on these? So the ones that I'm going to focus on is development, test, and production. All right. So development is when you're developing on your own laptop. Test is you're running your tests. Production is it's the real deal. It's live on the server. Okay. There is another thing called staging, which I will not really get into this semester, which is oftentimes after you've run your tests, you might want to rerun your tests on another machine called a staging server, which is usually set up to look identical to your production server, meaning it uses the same hardware, the same type of database, the same type of resources exactly, okay? Whereas in testing on your local machine, you might use some, like a little lightweight database, a fake message queue, or some fake resources, okay? But in staging, it's generally where you're trying out your software, but in an environment that looks almost identical to the final production environment, okay? But I'm not going to get into staging. Any questions about development, test, and production, though? Anybody? All right. So how do we inform our application which environment it's running in? We're going to use a simple tool that's built into your operating system called environment variables. All right. Environment variables are essentially just variables that your operating system and your application can share. All right. So, for example, I can make a environment variable called, let's say, username equals Somya. All right. This is now an environment variable that my operating system can access and any application running on my system could access. So if on Unix, the print command is echo, and I say, show me the variable called Somya, called username, and this will, oh, what happened? Exports username equals, huh? That's so weird. Do I have it set somewhere else? Let me first unset username. Okay, nothing. Export username equals Somya. Echo username. Huh? Oh wait, or maybe username is it a default? Let me try a different one. Is user, not username? Oh, user. For some reason, it's conflating user and username. That's so weird. My demo is crashing. Quotations, use quotations. Let me try a different one, okay? Actually, I'll show you the environment variable that we typically do use to tell our. Let me see if it first exists. So we usually use an environment variable called rakenv to tell our API what environment it's in right now. Okay. So for example, if I say export, and I hope this works, rakenv equals development. Please work. Yes. It'll say you are, so now rakenv is set to development. My Ruby application can read this variable from the operating system. And if it says development, then it'll know, oh, you want me, I'm in development mode. And it can make particular decisions based on that fact. Okay. And set rakenv. All right. If anybody's, okay, anyway. So that's environment variables. All right. If you, however, if you want to set up an environment variable just for one application to use, you don't need to export it to the, or let me go ahead and, did I unset this? Yeah. If you want to set up an environment variable for just one application to use, for one process to use, you don't need to export it to your whole operating system. You can simply set that environment variable just prior to calling your process. So usually I'm running rackup, right? Now what I can do is in front of rackup, I can say rakenv equals, let's say, test. Now when my API is up and running, my API can look for this variable in memory called rakenv, and it can find out, and it'll see that it is in test mode. All right. So this is one way to inform applications of certain parameters that you can pass from the command line. Okay. And so how does your Ruby application know what the variable, the rakenv variable is? Ruby comes with a built-in hash called env for environment variables. If you look up that hash and you give it the variable name you're interested in, it'll tell you the value. All right. So this way you can pass in parameters to your application. In our case, rakenv, this variable, to tell it what if it's in development mode, test mode, or production mode. And then in our Ruby code, we can run little if-then commands to say, hey, if I'm in test mode, do this. If I'm in production mode, do that, et cetera, et cetera. Okay. Okay. Any questions on environment variables? How to pass them in? Anything? Anybody? All right. So I think we have all the tools now to start talking about databases. All right. We have rake commands because there'll be to set up the database. There'll be a whole bunch of command line stuff that we have to type in. We can create helpful little tasks using rake. All right. And what else? Environment, we talked about performance and things, and environment variables, because depending on which environment we're in, we're going to use a different type of database, okay? Either a lightweight database or a serious production quality database. All right, before I go on, it's really, I'm feeling warm in here, but maybe because I'm standing in front of the projector. Is it warm in here or no? It is warm? Lower the temperature? Which button lowers the temperature? I hope that's it. I hope that's it. Does that, yeah, that's the temperature lowering button?
Yeah, lowering.
Okay.
I think it is limited.
No, it's limited to 20. Okay.
It's environment temperature.
That's the environment temperature. It is kind of warm in here. Is there a, and you said we can't run the fan because the fan needs power from a different source, right? Is that right? Could you, is this the fan? Could you try this out? Could you try to turn on the fans? Well, we have to turn on the lights. That's so funny. We have to turn on the lights to turn on the fan. If I turn on the lights, the fan works. Okay, hold on. Which light turns? No, it's now it's slowing down, right? So it's this one. Oh, is it speeding up again? Oh, it's the very lights that I don't want to use. Damn it. Okay. All right. Sorry. So I'm not gonna have that light on, but maybe we can open a window or something. The wind, it's maybe hotter outside. I don't know. All right. Okay. But yeah, please. Is just see if it's cooler outside or not. Is it cooler outside? Same temperature? But just having some air flowing is already helpful. A little wind. Okay, that's all we want. Okay, cool. Thank you. All right. Okay, so we're going to talk about databases today, and we're going to use everything we've learned so far to do this. Okay. Joe, I think just leave it alone. Leave it alone. I think we've got a few open windows already. Okay. Or you can try the other one if you want. Okay. Okay. So today's major topic is going to be, we've talked about some vulnerabilities and how to kind of take care of them, but today's major topic will be databases. However, I won't go into security aspects of databases. I'll do that next week, all right? So today is just to kind of show you how to set up a simple database and access it through Ruby, all right? So this is going to take a whole lecture because we're going to use relational databases. And I hope you've taken a database class before. It's kind of one of the prerequisites for this class. So the essential idea with a relational database is that the data is stored in tables. Okay, so it's kind of like Excel spreadsheets, but it's tables that are linked together. All right, so our database will be a relational database. The tables will look something like this, like a table with columns and rows. All right, so this is in tabular format, and relational databases store data in this kind of, or represent data in this tabular formats. Okay. However, this is not ideal for programmers because as programmers, particularly using object-oriented languages, we are not usually dealing with tables, we're dealing with objects, all right? Where potentially an object might be a row in a table, or it could be multiple rows in multiple tables, all right? There is not a one-to-one correspondence between objects and rows in tables, and that creates a lot of headache for programmers because on the one hand, we want to store our data in tabular formats because it has many nice properties. Relational databases, this kind of format has a lot of nice properties in terms of performance. However, ultimately, we want to get objects which might have data stored across multiple tables, all right, and multiple rows of multiple tables. So there's a mismatch between how object-oriented languages represent data and behavior, and how relational databases represent data. Okay. To bridge this gap, so for example, let's say I'm interested in a project. I may have a table in a database with like just one line with all the data about a project. That would be ideal. That would be very nice. But it's possible that my project has some other things. So in my case, in my software that in the application I'm developing called Credence, if you're working on a project, you would upload information about the project, and the project could have multiple documents like secret files. Okay, and one project could have multiple documents. So a project is not, to me, is not just a single thing. It's one row in the project table and maybe multiple rows in the documents table. All right, and this creates a huge headache. To be able to write code in object orientation and still have our data converted into the tabular format that relational databases use, we typically have a little library between our code and the database, which we call an object relational mapper. All right. Mapping means to essentially draw a link between two things. And what an object relational mapper does is it takes the objects that you are writing code about, and it can transform it into the relational design that a database needs. And the other way around, if you need data from the database, it can take relational data in multiple tables in a database and convert it back into the kind of object that you want. All right. So an object relational mapper basically translates between objects of OOP and tables of relational databases. All right. This semester, we're going to use an object relational mapper that I'll introduce in a moment. What do I want to mention here? I won't go into this right now. All right. So the object relational mapper library we will use this semester is called SQL. It kind of sounds like SQL, but it's called SQL. And it essentially eliminates, for most of us, for 99% of our needs, it eliminates the need for you to write SQL by hand. It will write your SQL for you when you simply tell it, what do my objects look like? What does my database look like? Now here's what I want. It'll just generate the SQL code for you. Okay. Now, if you write a actual application and it grows over time, you will find that ultimately there is a time when you need to just sit down and write SQL by hand yourself. But for most cases, you can get away with an object relational mapper. Okay. And object relational mappers come with a lot of other side benefits, which I'll discuss in terms of security, which I'll discuss next week. All right. So SQL is the gem we're going to use, and it's going to connect our Ruby application to databases. Which databases? SQL can actually handle a whole bunch of different types of databases. In fact, all the major databases work with this ORM. Okay, certainly Postgres, MySQL, and so on and so forth. Okay. And it comes with a lot of other nice things built into it. So one thing I mentioned is it comes with some nice syntax that creates SQL code for you, so you don't have to write SQL. It comes with thread safety, so you can make multiple connections to a database. It'll manage threads and do concurrent requests to the database as you need it. All right. It is an ORM package, so that's essentially what we're going to use it for. And it supports many advanced database features. If you're a big fan of Postgres or something like this, you'll know that different databases have some particular capabilities, and the SQL gem is developed to kind of be able to access those unique capabilities of certain databases. Okay, so and it has adapters for any database that you can connect by ODBC, JDBC, or any other possible way. All right. What am I going to get into? Let me show you a little demo of what I mean by an ORM and what it does for you. So let me run this little, run a simple demo first, and then we'll kind of get into, well, how do you make a database? How do you define the database? How do you connect your code to the database and all that stuff? But let me show you the end result really quickly. All right. So I know I have a couple of databases already in my application. They are in app DB store. Okay, I've got two database files. One is called development.db, the other is called test.db. These are local databases that are like on my computer right now. Of course, I don't have a production DB because that would be on the production server, and it wouldn't be a little .db file. It would be a full-scale production server. Okay, I want to access the test database because I know that's probably populated with some data that I need. So I'm going to, so now what I want to do is I want to open up IRB so I can type in some Ruby commands, but I also want that IRB to like load all the code of my API so that I can call all the different classes of my API, okay? So to do that, I would have to call IRB, and within IRB, I'd have to start requiring all my files, okay? I do this so often that I simply made a rake task that does this for me. Rake console, all right? This opens up IRB, and it loads a file called test load all, which basically goes through my whole code structure and loads all my classes for me. I'll show you what that does later, okay? But the essential idea is that I've made a little task called rake console. If I look at my rake file, where's console here? Console. So what I'm doing is I'm essentially running IRB, and I'm telling it, please require this file. Spec is in the spec folder. It's called test load all. All right. Oops. Excuse me. All right. And test load all. What does it do? Well, I'll show you later how it loads all of my code across all the files in my application. All right. So Rake console essentially does that for me. Excuse me. All right. Now, I want to run this in the test environment because I wanted to access the test database. So I'm going to set rack env equals to test, and then I will run rake console. Okay. Let me start showing you how, once everything is set up, which we'll spend the rest of today doing, but if everything was set up already, let me show you how easy it is to talk to my database. Okay. So remember, I have this week two models. One is called project, one is called document. Okay. So users coming to my system, they can create projects, and for every project, they can add multiple documents. All right. So to access the database and to get the projects, all I have to do is the namespace of the module my entire application sits in is called Credence. What's the name of your application's module? Check? Check high? Okay, all right. Mine is Credence. And within it, I have a model called project. Okay, or last week I had something called document, right? So I have document still, but I made a new one called project. All right. And what is it? Well, it's just a class. What can I do with it? I can ask it, what are all the projects in my database right now? Bang, and it'll tell me, it returns to me an array of projects. Okay, so this is an array of multiple projects. Here's the first project. Its ID is 71. Its name is test project. Its URL is here. And what else? It was created tomorrow, miraculously. All right. um, and so on and so forth. Okay. So I can, oh, and by the way, I'm going to do something that will allow me to see the projects in a little bit friendlier format, and I'll show how to do that later. Ta-da, tabular formats. All right. So this is showing me these are all the projects I have in the database. And actually, what this is returning to me, if I ask what kind of class, what kind of object is this returning, is returning an array to me, actually. It's showing it in tabular format right now, but it's actually an array. All right. So since it's an array, I can do stuff like, oh, from all my projects, could you give me my first project? And bang, there's my first project. All right. And I could say, in fact, I may not even need all. I can maybe just say project at first. Yeah, it'll give me my first project. That's cool. And I say, hey, what's the name of my first project? It'll say it's a test project. All right. And or I could ask, where is the URL? Like, where is this project? It's on GitHub. Here's a link to it. All right. Or when was it created? I don't know why this date is wrong. I have to figure that out some other time. But it was allegedly created. Oh, today. Oh, it is today. It is today. It is. Oh, yeah. It is today. All right. Excuse me. I forgot. I thought today is the 22nd. It's the 23rd. Oh my God. Time goes by. Okay. That's cool. But remember, I also said projects have documents, right? How can I find the documents that belong to this project? So first of all, let me just call this proj1. All right. So, oh, oops, excuse me. What just went wrong? Wrong number of project first. Proj1 is equal to, maybe it's a problem with this. It's a known problem. Ah, it is a known problem. Herb has a problem. Okay. I'll fix that later again some other time. So here's my first project, and I call it proj1. Okay. Now I want to find out what are the documents associated with this project. Now the problem is the documents are not stored in the same database table as projects. It's a different table called documents. All right. I could ask Credence. I could ask Credence. I could ask my application. What are all? Oh, there's no documents in here yet. Hold on. Let me run my test because usually my tests populate my test database. There we go. We have some documents there now. All right. All right. And here are my documents. I have. Let's take a look at the first document. Okay. By the way, how can I? The first document is. So this is the first document. Oops, excuse me. Okay. And it has, a file name. Oops, name. It has a description. All right. And it has some contents which are not encrypted for today. Right? And that's the contents of that file. All right. So that's nice. What if I wanted to find a particular document? I could do this. Document dot find, and let's say 83. Does that work? Oh, no, that's a project ID. Yeah, sorry. Find ID. Does this work? 27? Find index. No, not working for some reason. All right. Let's just do first for now. Well, let me look at my notes here. Find ID. Oh, okay. I see how to do it. I have to say find. So document at all. So let's say I just want to get one document with, let's say, file name another.yaml. So I could do document.find, and here I could tell it I'm looking for file name another.yaml. Oh, this has got to be in quotes as a string. Okay. And this tells me, here's your document with this file name. All right. Or I could say, find me the document that belongs to project ID 83. That's two that, and it shows me the first one. That's weird. Dot all? No. What's that? Okay. I should return a couple of them to me, but I don't know. Let's see. So this is some things that I can do to talk to my database just through my ORM. Okay, so now I don't have to write SQL commands by myself. I could do this. I could say where project ID is 83. Okay, you notice when I do that, this actually shows me the SQL command. This is an actual SQL command, a select command with a where statement in it. And if I do .all, it will get me all the results. All right. I think find just finds you the first thing, not all of them. All right. So if you're searching for multiple hits, then you use where.all. Okay. So this is, I think, though, still easier than writing this big SQL statement out by hand. Okay. So now here's an even more powerful thing. So remember, I had proj1. I gotta fix this eventually. Remember, I had undefined. Proj1 is equal to, where's proj1? The first project, okay? So this is my first project. If I want to know what are the documents that belong to this project, the hard way of doing it is I could say proj1.id, that's 83, and then I could say, you know, credence document dot where, what was it? Project ID is proj1.id.all. Huh? Okay, that's the hard way of doing that, is like, where are all my projects that belong to this project? There's actually an easier way of doing this. So proj1 is the project that I got. I could simply say, what are all your documents? Bang, it tells me these are all my documents. All right. The object relational mapper is intelligent enough to know that these project is linked to multiple documents, and I can simply ask it, what are my documents? And it tells me. All right. Similarly, I could document credence, credence document. Let's take the first document. I could, I believe, ask it, I could ask it, what project do you belong to? And it'll tell me this document belongs to this project, and it returns information about that project. Okay. So I'm able to access a relational database using this object-oriented notation. Get a project, ask it, what are your documents? Get a document, ask it, what is your project? And it can link between all the tables in my database. All right. So this is essentially what an ORM looks like. I could also create a new project. So let's, using commands like this, I could say credence project.create, and then give it the necessary attributes like name and URL, and would go ahead and create the project for me. Okay. If I had a project already, so like let's say I have this project called proj1 already, I could add a new document to it. So the code for that is here. I could say .add document, and what do I have to give it? File name, and I'll call this my secrets .txt. Okay. What else do I have to give it? Description. Okay. My project secrets. And what else do I have to give it? The content. Okay. And this is my secret. If you're wondering why I keep having typos, it's not because I'm drunk or something. My keyboard actually has a problem and I'm waiting to replace it. Okay, I promise. So this is cool. I can add a document to my project just like this. Okay, like I said, given this project, add a document to it. Bang. All right. Now, if I look at credence document.all, there will be one more document in here called mysecrets.txt with this description, contents, etc., etc. All right. Okay. What else can I do other than add documents? I think I've shown you most of the other ones. Here's one more. It's called update. Given a project or a document, I can update it, and I can update just one attribute of it. All right. Or if I wanted to delete, so now remember, so I've got this project, proj1, right? And it has now how many documents? 3 documents, right? What if I wanted to delete this project? Would that create a problem? potentially, because I've got documents in the documents table which link to this project ID 83. I would need to delete this project and all its documents, otherwise I'll have some orphaned documents that don't belong to any project. How should I do that? The long way of doing that would be to find all the documents, destroy them one by one, come back to my project, and then destroy my project. Here's an easier way of doing it. I can just say proj1.destroy. This has now project.all. This has now removed that project from my project table. Project number 83 is gone. What about my documents? All the documents are gone from my database as well, because they all belong to this project. So miraculously, I was able to destroy a project, and the ORM figured out, hey, this project has many documents associated with it, and it goes ahead and destroys those documents as well. All right. This is the power of an ORM. It essentially allows you to do all this powerful access, query, update, deletes, creates on your database, all through what looks like relatively object-oriented code without writing any SQL. In fact, without even knowing that there are tables under all this stuff, multiple tables under all this stuff, okay? Out of curiosity, how many of you have used an ORM like SQL before? Okay, for those of you who have not taken my classes, what ORM have you used? I can't hear you. Entity framework? In which language is that? C#. So you've got an ORM called Entity Framework. Cool. I saw another hand here. Brandon, was that you? Which one? Active Record, right? Okay, that's probably the most popular one for Ruby is called Active Records. All right. Anybody else? Anything else in any other language? No? Okay. Well, then it's a treat for you because you don't have to write any SQL this semester for the most parts. Okay. Okay, let's take a little break. We'll come back and I'll show you how we're going to set up the database. So the ORM I showed you, it has all these magical properties, but it does take quite a bit of setup to get this working in the first place. So I'll show you how to do the setup after we take a quick break, okay? So it's 10:35 now. Let's get back here at 10:45 and we're going to get going.